The beauty of the endless details of fractals is that they are not made from exotic formulas. They spring from the same simple formulas that you learned in school to draw a simple static geometric object like a parabola. The crucial idea that Mandelbrot used in order to unlock the dynamic side of geometry, which is fractal geometry, is iteration. And iteration is just feedback. Take a formula. You feed a number in, you get a number out. In the old days, you would use this number to put a dot on a piece of paper and draw a curve. Now you don't do it anymore. You take the number you've just obtained and feed it back into the formula. So you get another number, and you feed it back again, and so on and so forth. Now let's look at the formula for a parabola. You take a number, you square it, and you add a constant to it. Let's choose a number and run the program. The numbers on the left, generated by the formula, are plotted on the real line and then fed back into the equation to generate the next number, and so on. But the line isn't the place to draw pictures because it's one-dimensional. Pictures are two-dimensional, so to draw them we need two-dimensional numbers. This may seem strange to you, but using two-dimensional numbers, the complex numbers, is the very first thing that would occur to a mathematician. You see, complex numbers give breathing space to ordinary numbers by unfolding them. And this is just what occurred to the French mathematician Gaston Julia, who actually taught Mandelbrot. He did not have a computer then, but was able to imagine the extraordinary objects that a repeated rule could create. The Julia set. The simplest of rules has produced a geometric monster, a fractal. This is the monster that Julia brought to life. The Julia set is to fractal geometry what the circle is to school geometry. But unlike the circle, the Julia set isn't a single shape. It is a set of related shapes, all born from the same formula. There are, in fact, an infinite number of different Julia sets, which depend only on the value of the constant you start with. So, as you change the constant, the Julia set changes. And if you put one set after another, you see how Julia had unleashed not one, but a whole bestiary of wriggling monsters. The great discovery Mandelbrot made was to find a unifying pattern, which brought order to the zoo of fractals discovered by Julia. People knew that by changing the parabola rule, the constant you add after squaring, the shape of the Julia set would change. They also knew that there was an infinity of Julia set. What they didn't know was if there was any pattern linking them, or if it was just random. What Mandelbrot did was divide the Julia set into two families, those made of a single piece and those disintegrated into infinitely many fragments. Then, using a computer, he marked in blue those values of the constant for which the Julia set is made of a single piece, and in color, those for which it is not. And in this case, he also color-coded their degree of fragmentation. What he found is one of the most extraordinary mathematical objects ever discovered, the Mandelbrot set. It is a complete library of Julia sets, where every dot, every single detail, represent a different Julia set. In one infinitely detailed picture, Mandelbrot has described how all the Julia sets related to each other. The Mandelbrot set is a map of the world of Julia sets, bringing a dimension of order to it.
When I first saw what came to be called the Mandelbrot set, I had my usual feeling when something important happens. Initially a feeling of exhaustion, and then a feeling that I must explore it, that this is something I don't know yet. I must become familiar with it, I must play with it. And the play, of course, meant in this case, make pictures of it. So we spent nights sitting in front of the computer and just this thing blowing upon us. And very often we wondered whether it was real or whether we were dreaming and were pinching each other. It was a feeling of, at the same time, of great fatigue and extraordinary joy. But this feeling that somehow this thing must be understood, that we have stumbled upon something which was not an everyday event, was very, very strong in our minds.
Just as Mandelbrot added a dimension of understanding to the work of his teacher, Julia, so colleagues of Mandelbrot have gone on to explore higher and even more remote dimensions of fractal geometry.